Alright folks, welcome to the Perceptron model. It only took a few videos, several cups of tea and possibly 3 high school graduation degrees to get here. But hey, we made it. Now let's keep it simple. What is neural network? So a neural network is kinda like a knockoff version of how your brain works. Just like how a brain neurons take in some signal and does its things and spits out a result. We build a mathematical version of that which is called as perceptron. Now I am not a biologist, so let's stick to what we do know. That is nothing but maths and code. Now let's see one simple network here. Okay, so in this network we have something called as nodes. These are nothing but your nodes. These are like the brain cells of our model. Each one holds some number. Say here I will give some first node as 5. The second node, let it be 3. Let me just connect this network. Now we have something called as weights. Think of this like knobs that control how much influence this one node has on this next node. So that is nothing but weights. So let me give some value here. Let's say the value of my this weight be 2 and the value of my this weight be 3 again. Now both these nodes are connected to a single node in the next layer with some weights value, and these are nothing but some input values in it. So how do we get the value of this node? We need the answer right here. So easy. What we do is we multiply the node value with its weight values. Okay, and then add them up. So let's see for here. First what will happen is, say this is nothing but, let me give you the conventions as well here, it will be easy. Let this node be x1, let this node be x2, let this weight be w1, let this weight be w2, and this is nothing but your output, so let this be y. So for y, for first what we will do is x1 w1, okay, plus x2 w2. This will be nothing but your y. So now here x1 is what? 5 into w1 is 2, correct? Plus x2 is what? 3 into w2 is again 3. So what will be this? 10 plus 9. So that is nothing but 19. So this is your y. Okay, so now we have a value of y which is nothing but 19. Boom, that's the value passed to the next node now. Does it look familiar? Yeah, it's a dot product between the values of the nodes and the weights, connecting them to the next node in the next layer. So say this was your layer 1, correct? This is your layer 2. But for now, for simplicity, we call this as input layer. The very first layer is nothing but the input layer where you pass all your input values, and the very last one is called as output layer. So there is one more concept called as hidden layers where we add multiple layers of such networks inside this neural network. But for now, as we are seeing a perceptron model, it is a basic one layered neural network. So now it's nothing but a dot product of your node value and your weights, connecting them to the next node in the next layer. But don't stress about the same. Just remember this. What we did was, here we had value 5 and here we had value 3. This input layers. We did dot product of it with what? Weights, which was nothing but for w1 2 and then w2 3. Then what we did was multiplying each input by its matching weight. That means what? Here we have 5. So its matching weight was what? X1's was w1 and x2's was w2. That's not important right now, though. Just take away these rules of a network. Every node in the layer connects to the every node in the next layer. Now these connections have something called as weights, which are just a number, and remember every weight has a predetermined value. Okay, so these values are predetermined. Next rule, only the first layer which we have is called as input layer. Okay, which has the values to start with for neural network, and all other layers Their values are calculated using this input node values and the weights for the next. Okay, so yeah, it's like a chain reaction of math, which we saw in the previous video, that was derivatives and partial derivatives. So I'll suggest you go through it once. It will make your understanding much easier for the upcoming topics for neural network. Alright now, so now that we have got the basic idea of perceptron, let's turn up the heat and look at slightly bigger problem where we will see what now? Now two-layer network. Let's see one more network that is nothing but a two-layer network. Let's go. Now say input layer has two nodes. Then we have one more called as hidden layer. This is nothing but two-layer network. Okay. Say here I have value 3. Here I am taking value 2. Now as we learned earlier that each node is connected to the next node of the network with some weights. Okay, so first let's connect the network. So here I will just make the connections. Then this is also connected to this. This is also connected to this. Now we know that each connection has some weight. So let's give them some weights. Say here this weight will be 4. Let this weight, this one be 7. Let this be 8 and let this be say something called 10. Now we need to calculate this value and this value. Now check on this node what inputs are coming. One is this connection, one is this connection. So what multiplication we need? So that will be nothing but 4 into 3, correct? This 4 into 3 plus the next connection is what? 8 into 2 plus 8 into 2. So that is nothing but 12 plus 16. So here we got the value as 28 after calculation. Similarly, we'll calculate for this. Here it is coming this first. So that is nothing but 7 into 3 plus it is coming 2 into 10. Correct? So this is nothing but 21 plus 20. So that is nothing but 41. Right? Right? No? Yeah, right. So here we have as 41. So always remember, whenever you want to go bigger, let's generalize it how it gives. If you have 3 nodes, say if you have 3 nodes in first layer and then you have something called as 5 nodes in second layer. So instead of 2, you have 3 nodes here and here you have 5 nodes in this layer. Then each of these 3 nodes will connect to all of these 5 nodes in the next layer, correct? So that means how many total number of weights we'll have? That is nothing but 5 into 3, that is 15 weights we will have total. Okay, so this is generalized. Say you have n nodes in first layer and m nodes in second layer, you just multiply them and you get a total number of n into m weights. More generalized. So each node in the next layer is really just doing a bunch of multiply then add math with all the inputs it's connected to. Alright, just one more piece before we wrap up the structure of a neural network. Let's talk about biases. So we are talking about neural network biases, little number that can make a big difference in your network. So here's what's happening. After we do that whole dot product thing here, which was nothing but this multiplication and then get the value for the next node in the next layer, we then add one more number. So this was the multiplication for all, correct? With this, along with this, we add one more number, something called as biases. Think of it like final topping on your pizza. So instead of just taking this weighted sum, which is nothing but this node value into weight, we also add some biases for each node. Okay, so which will be nothing but this weighted sum plus with some bias. Now why bother with the bias? Let's say for some weird reason, all the weights of your networks become 0. Yeah, that's bad, right? Because everything will get unconnected, then all the multiplication value will become 0 and there will be no connection between the nodes if the value is 0. So without a bias, every single neuron in the network would end up this computing 0. Every layer would just pass on these zeros further, okay, and the whole network becomes basically brain dead. But a bias fixes that. So even if say some weighted sum is 0 and we add a bias as little kick, okay? So the neuron doesn't just die out. It keeps the network alive and thinking. Now let's visit this example of our two-layer network, okay, with some biases added. Let's say the first node in our second layer gets a weighted sum of 28 here. And then we add some bias to it. I am adding some bias to it whose value I am giving as 1. And here I will give some bias whose value I will be giving say -5. Now every neuron except the neurons into input layer, every neuron or node has its own bias. Okay, so all right, just one more piece before we wrap up the structure of a neural network. Now after adding this bias, what will happen is my value will change from 28. Okay, 28 plus I have added some bias to it, which was nothing but 1. So the value of this node instead of 28 will now become 29. Similarly here, it is now 41, but I have added the bias as -5. So the value will become what? 36. So this instead of 41, the value will be 36 for this node. So every neuron get its own personal bias value. So we have built the whole network structure now. We have nodes, we have weights, we have biases. You might be thinking, but like, wait, how does this thing actually learn? Like, where's the smart part of the network? Now there is something called as neural network intuition. Remember those dials we talked about earlier when we discussed derivatives? If not, go to the previous lecture of derivatives and have a look at it. Well, weights and biases are nothing but basically those dials which we were talking about. So in a telephone, you have something dialing continuously till you reach to the end of that number and then your call gets connected. So this weights and biases are working as those dial. These are the only parts of the neural network we can tweak to get better prediction. The input layer, it's just a raw data. You can't change that. The nodes in the hidden layer, they are just reacting to the previous layer's output after the calculations. But the weights and biases, those are our secret levers to control the network. The neural network's job is to adjust these weights, whatever we have, and the biases which we are setting it for each node to make the better prediction over the time. It does this using something called as cost function. Let us call it as capital C. This tells us how far off was your prediction from the actual value. So the computer goes like, the cost is high. So let me tweak the dials, which are nothing but our weights and biases, to bring this cost down. This magic happens using gradients, specifically represented as nabla of C. This is called as nabla. We have seen this in the derivatives lecture. I am suggesting again, please go and have a look. So this is nothing but a derivative of a gradient, that is gradient C. This was all about it. So let's have a quick recap. What's inside a neural network? There are four main ingredients. That is nothing but your nodes, okay, which are nothing but your little data holders. Then you have something called as weights. Yeah, this is just how strong each connection is to the next node. Then we have something called as biases. Okay, this is just an extra boost or nudge for each neuron. And then we have something called as cost function. Tells us how bad our predictions are. Here's how neural network runs step by step. First, we feed some input data. So here we have 3 and 2 are input data to the first layer. Then this data gets multiplied with their respective weights, and then we add some bias to it, and then this we all pass this through and then pass through a function to activate each node. Okay. Now this keeps going through each layer like a game of telephone until we reach the final layer. The final layer spits out a prediction. Whatever final layer we'll have here, this will spit out the prediction. Then we compare this predicted value with the real answer, okay, and then calculate this something called as cost. Don't worry if you are getting confused here. We are going to see this in detail in the next lecture, but I am just giving you an overview of how a neural network will work. Okay, then we figure out how to update this weight and the biases to reduce this cost if it's too high using our trustly gradient called as delta C or nebula C. We repeat this process over and over until the cost is as low as possible. That's what we call as a training in machine learning in a nutshell. Now some golden rules to remember again. Every node is connected to the every node in the next layer using something called as weights. Now weights are initialized randomly but are updated using this gradient. Every node except the input layer have something called as biases which adds after the weighted sum. Now biases are also initialized randomly. The network learns by adjusting these weights and biases to minimize the cost. So yeah, neural networks are basically like big machines with tons of dials and we use calculus to fine tune those dials until the final prediction starts making sense. Pretty cool, right? And now that we have got the intuition, you are officially ready for the notation part of a neural networks. So stay tuned for the next video where we'll jump into the notation and build up a perceptron model, the first real neural net in action. You have come so far already, so let's keep the momentum going. Thanks for watching.